All right, so good afternoon, everyone. One moment, let me adjust the screen. All right, so our previous lecture stopped at Jetpack 2000. So before we proceed, we proceed with Jetpack 2000. Perhaps we can have a recap on this chapter. So basically, this chapter include. So basically, this chapter includes the basically in terms of principle of data compressions, we are concerned in two different items. First of all, the bandwidth. Second, limited storage. So these two items, okay? Since we because multimedia, the main purpose of multimedia is to communicate. Always remember the definition of the multimedia. Multimedia is actually multiple medium, and this multiple medium is not just put together and that's all. Okay, not something like that. But rather, these multiple mediums are putting together, and there are interactions between this medium, and of course, involve and engage the human being. Okay, so this is the definitions of multimedia. So since this is a multimedia engaging human, and that is why the main I mean the main people who decode and encode the multimedia would be human, which means the main target is also human. So that is why in image compressions, audio compression, and video compressions, the main audience or the user would be human being, okay, not machine vision and etc. Okay, since the multimedia is meant to communicate with each other. So it is inevitable that we will send the data or the any other any mediums, for example, text, video, or data in any other format to another people. Okay, so by sending the data to one another, we need to transfer the data which involve the bandwidth. Okay, so that is why we have different kind of bandwidth, for example, uh, 5G, 6G, and etc. So that is the principle of data compression, that we want to send a very high quality information to someone else, but this may slow down the entire sending of data. I'm not sure if you all ever experience, uploading a file to the email, and the email telling you that, oh, the file is actually too big, and and the email can accommodate this. Or you want to upload something very big to the drive, so the drive will say, oh, the upload is very slow due to internet and this and that, and then your upload always maybe pause halfway, or maybe cannot upload due to long responding time, something like that. Okay, so that is involve the sending of data which require the bandwidth lah. Okay, the another thing is the limited storage. So we all have very limited storage. What I mean by limited storage is, which means the storage is not unlimited lah. No matter your hard disk, your pen drive, and etc., you all have a limited or finite value of storage. So since you have finite value of storage, if the incoming multimedia is at a static or at a low stage, so then should be fine. But if let's say for those semiconductor industry, they have incoming lot, for example, 6,000 units per lot, and this lot is like 3 to 4 hours to complete. So one day perhaps you have few lots to come in, and this incoming lot is like 24 hours run whole in a whole week time. So perhaps no matter how many GB or TB you have lah, it won't be sufficient because the incoming lots or the incoming units to be storage in the local drive is increasing exponentially. Okay, so this is the basic, I mean, principal data compressions, that why we need to do data compression is applicable to audio, image, and also video. So we also know about the lossless and lossy. So lossless is that we have no data loss. Okay, we still perform the conversions, but actually there is no data because the those compressed information can be decompressed later on. Okay, so by doing so, you would expect to have, for example, the original data is like maybe 10 GB. After lossless compression, perhaps you can get 7 GB. Then later on, you can recover to become 10 GB. So this is so-called the losses lah. And the advantage would be it can be recovered. Okay, it can be recovered. But the disadvantage is that the compression ratio is usually small, okay, as compared to lossy data. So for example, you have another lossy data, maybe you can become 1 GB, but this is not convertible to become 10 GB. You would forever to get 1 GB. Okay, the main advantage is that you can compress any medium, I mean not any lah, but some of the medium depends on the extension. For example, Jetpack, you can convert it to a smaller data or the file size with a greater compression ratio, but you cannot convert or decompress or decode back to the original file size, which is 10 GB. Okay, so this is the difference between lossless and lossy. And always remember, in Jetpack compressions, we are usually performing the processor data compression process in a 8 times 8 or 16 times 16, either way. But in most of the time, I mean by default, we're using 8 times 8 lah. Okay, so we also learn about the Jetpack compression and Jetpack 2000 later on. So let us move into Jetpack compression. Where is Jetpack? Okay, so this is the general flow chart of the Jetpack compressions, whereby you usually start with the input image, which is input image, which is the color RGB lah. Then later on you convert to YCBCR and then subsampling using 420, and then you divide it into 8 times 8 pixel group. So when you divide into 8 times 8 pixel group, and let's say you have insufficient uh, pixel here, so you will need to pad it with extra pixel, okay, so that you can actually, I mean, end up separate all the pixel, I mean original pixel into 8 times pixel group. Okay, always remember the image processing is unable to process any empty pixel, so padding is the easiest and the, I mean the most common way to compensate the missing pixel. So there are three types of padding: zero padding, reflection, and also mirror. So you can refer to the previous chapter to record this one. So after we break into, I mean, after we characterize in the 8 times pixel group, we will perform block shifting. Block shifting is nothing but to minus by 1 to 8. Okay, this is to shift the entire. This is to shift the entire uh, uh, input value, which is 0 to 256, to make to match the sine wave. Okay, to match the sine wave. So by minus 1 to 8, you will get able to get a negative value as well lah. So please do not be surprised if you I mean if you have negative value after perform the block shifting. So this 8 times 8 pixel group is then undergo the DCT. After the DCT, you will get these DCT coefficients. So in this DCT coefficient, you will perform the quantization. So quantization is actually divided by something else, and the table is provided by the Jetpack group. Okay, so this is the example. So let's say you have 512. So since this is the quantization table, so 512 divided by 16, you will get 32. Let me take another example. For example, 2. divide by 100, you will get 0 because the value is too small. Okay, the same apply to the negative value. For example, negative 4 divide by 77, so you will get 0 as well. Okay, so don't worry, if let's say this question is appear in your examination, the quantization table will be given. Okay, no memorization is required. So after your quantization, always remember the quantization is performed, is supplied by the Jetpack. And after you perform the quantization, you would have the DC value and the SC value. But actually, after you get this step, I mean, after you complete this step, you would have your DC and SC value. Just that you haven't performed any quantization. So the DC value is always this one, the one at the top left. Location information, the bottom right would be high frequency information. So for image that is I mean most of the common image lah, the value at the DC value would be higher because it is normal to have a slow transitions of a pixel in most part of the input image. Okay, because let's say we capture an image, an apple inside. So all these the background, the red color of the apple, all these pixel value actually it has only very small rate of change. Okay, that is because for example the red color of the apple, the distribution of red color of this apple might not be the same throughout the entire apple, but the rate of change or the discrepancy is small. Okay, the same apply to the background. The change, for example, this background is a green background lah. Okay, due to illuminations, arrow, the shading of the apple or the ambient light, it's normal to have a different intensity. Quite rare to have, for example, this is a white background. For example, 250. It's not so possible to have a purely 250. I mean, standard 250 pixel across the entire background. That is because this, I mean, when during the capture of image, the lens itself, the illumination different, the ambient light, and many other factors may change the value of this background. But nonetheless, the background should be in overall still remain as white color. Okay, which means maybe the value is not 200 sharp across the entire background, but perhaps maybe 190, 170, 250. Then sorry, 190 is too less. Perhaps it would be 240, or maybe 248, or maybe 230, something like that. Okay, so this would be the and all this when you calculate that is only a small rate of change. Okay, so that is why in most of the time the DC value would have a higher number, which means most of the image, most part of the pixel in this particular image has a very low rate of change. Okay, so if you have I mean the value at this part is quite big, or perhaps you have any positive value at this part, for example 1 2, or maybe suddenly there is a 50 over here. Perhaps this we can actually say that this image perhaps is corrupted by noise. Okay, that is because the noise, for example salt and pepper noise, salt and pepper noise, black color would be pepper and white color would be salt. So salt and pepper noise is an cliche example of impulse noise, because the value of black and white would be 0 or 1, no matter after or before you normalize it. Okay, so the value of salt and pepper is very very different towards the adjacents. For example, you have a red color apple and suddenly there is a black spot here, and the black spot is actually pepper noise. So and it is not the pigmentation occur on the surface of an apple. So that is why when you have this kind of black color dot, the change of value, the change of the rate of change of the pixel intensity is very big. But of course, if let's say you have totally black color background, and then it is corrupted by different salt and pepper noise. You wouldn't expect to see any changes because since the background is black color and you have the pepper noise which is very subtle. Because the background is black color, right? And here, although the image is corrupted by the pepper noise. Okay, do you understand this? Which means we cannot just directly say that, oh, this pixel is this picture or this input image is actually corrupted by pepper noise. So there must be the value at this area would be higher lah. Not a must because we always check the rate of change of the pixel intensity. Okay, so after you perform the quantization, you would have DC value and also SC value. And for DC value, you need to perform the DPCM. And for SC value, you need to perform zigzag ordering followed by RLE. So zigzag ordering, so the DPM is very simple. And as I mentioned previously, we always want to figure out an alternative method to reduce the storage size. So let's say the original, or the first value of the DC is 150, and the subsequent is 155, or 148, 152, and 144. So in this circumstance, the first value is 150 is you cannot really remove this one because you need this value to calculate the subsequent one. So the subsequent value is 155, which means there is a difference of 5. Why I put a positive sign here? Actually, you don't need to put the positive signs because the sign here reflect that you need to add in another 5 blocks. Okay, then you will get 155, and then later on minus by 6, you will get 149, and so on and so forth. Okay, so this is how we actually perform the DPCM. And then we perform for SC coefficient, we perform zigzag ordering and RLE. So the zigzag ordering is actually something like this one. Always remember to not run at the wrong directions. Do not run at the wrong directions. Always remember to start out from the left hand side. From the right hand side. So you would have something like this. It is very, very similar to the scanning of line, the line scanning in the video processing. So for example, the 8x8 quantized DCT coefficient in the block below is 32, 6, -1, and blah, blah, blah. With 3 runs of 0 in the middle and a run of 57, 0 at the end. So which means you have 3 runs here, and this is another 51, 0. So we look into the example. So the run length encoding is applied to the 64-bit, replacing the value of running, okay? Basically ILE, you just need to recognize ILE is only for AC. For DC, it is, in practical case or most of the cases, it is actually save or store it separately from the AC value. Okay, so the first value here is DC. So we I mean create this run length. So basically you just need to identify how many 0 between the first, the previous value and the current value. Since there is 0, 0, 0 there, so you have a 0. The next value is number 6. Okay, and again, is there any gap? No, so 0. What is the next value? -1, which is this one, and then followed by any gap between this and this? No, so which means again 0 and -1, which is the next upcoming, and then any gap between -1 and -1? Yes, 1. So followed by -1, and so on and so forth. Okay, so that is how you obtain this one. And for the last one, since everything is 0, you can actually use 0, 0 to represent the end of this run length. So after that, you perform entropy coding. After entropy coding, you will get a stream of values such as this one. Okay. Since this is a computer science, when you do the value, when you do the algorithm, it is very much associated with the computer science. So that is why usually, not usually lah, just that how far you go But basically, if you walk into the doorstep of the uh, computer science, so for sure, everything, the answer, everything regarding this one would be end up as 1 and 0 lah. Okay. So here we learn how to get the 1 and 0. I mean this bit stream. We have different table to record this one. I mean to learn this one. But the table, I mean the full table is not within the slippers. So basically, if let's say part of it is required, so basically it would be given. For example, the value for -8 is this one. So you just need to retrieve the data from the simplified table. This is the size and value table. Basically, you just need to obtain the size and the value and the size, value and the code in the table accordingly, and then obtain the size, and from the size you can get the another set of number. So basically combine these two sets, you get 101 and 0101. Okay. So the same bit different. It's not storing 40. For example, in previous case, um, you have all sort of value. When is it? You have all sort of this value. For example, 150 is the start point, followed by 155, followed by 149, so on and so forth. Okay. So since you have 150, which is the primary, I mean the first value, you cannot really remove this value and represent with something like -x, something like that. Because once you remove this, the reference uh, for the subsequent coefficient would be lost lah. Okay, so since you have 150, so the next one is 155, right? So what is the difference, which is 5? So you just need to solve 5. And for 149 to 159, what is the difference? You have a difference of -6, and so on and so forth. Okay, so that is how you store this value. And for the example here, we are actually proposing an example of -8 lah. One moment. An example of -8. So and assuming the previous one is 40 lah. So the value difference would be -8. Okay. So first of all, go to the size and value table, get your value, which is -8. So since the value of -8 is represented by this value 0, 1, 1, 1, and refer to the size value here, because you need the size to know the actual storage required for this particular code. So after you get the code, you can go to Huffman table for DC component size, and based on the size, you get your code. Okay, that's all. And then you combine both of these 101 and also 111 and also 111. Is it correct? 101 and 111 to combine and become this bit stream. Okay, and continue to do for the rest of the AC. So for AC, it is a bit different, but basically the theory behind the AC and DC, I mean how to convert and to change it to become the Huffman coding is actually very, very similar. Okay, so AC coefficient are coded as S1 and S2 pair. So basically S1 is the run length and size, and S2 is the value. Let us go into the example. Considering encoding AC coefficient, which means the rest of this, which is excluding the 40, because 40 is DC value, but arranging them in a zigzag order. 12, 10, 1, -7, 2, 0, and 4, and then 5, 56, 0. Okay, so always remember to start from the left hand side and so on and so forth. So after ILE, the value reads at 0, 4. Okay, and the obtained code is this one. Okay, so first of all, you need to know the value of 12. Where is 12? Oh, I think I missed a 12. Sorry. Oh, yeah, no, it's correct. The first value is 12. The DC is 40 lah, but I did not include the DC here lah. Okay. So first of all, the first value is 12, right? So when you write in ILE, so you're supposed to get, because zero gap between these two, so 0, 12, and then 0, 10, and then 0, 1, and then 0, 1, -7, and then, sorry, yeah, correct. And then 2, 0, -4, 2, -4, and then 56, 0, 0, 0. Okay, so this is the end of code, which means reflect the end of code. So the first value is 12. So from the size and value table, you get the 12 and get the code. After you get the code, refer to the size. Okay, and go to another size table. Since you have zero gap here, so which means your value will be 0/4 lah. 0/4. Okay, so after you get 0/4, find the table exactly at 0/4 and obtain this code, and combine this code with this code. Yeah. Okay, so we have these two code, and then you will get the value lah. Okay. So this is the DC value where we obtain this using DPCM, and the rest will be SC value. Okay, so basically you just combine the full bit stream would be something, I mean, looks like something like this lah. So for JPEG 2000, the joint photograph but processing. So it's under both the Internet ISO. The JPEG committee has defined and published a standard which is JPEG 2000 to anticipate the needs and requirements of next generation imagery application. Always remember, we did not really use DFT, but we use DCT, which is for JPEG, and DWT, which is for JPEG 2000. What is the difference between DCT and DFT is that DCT does not require any calculation of complexity, which is the imaginary part. So which means the calculation of DCT would be simpler than DFT lah. Okay, but anyhow, both of these DCT and DFT, uh, they are actually in frequency domain only. So which means when you convert something else to another domain, you will lose the original image data, okay, or the image information, I would say, okay, and then your information is not available in another domain, okay, frequency domain in this particular case. So I mean the JPEG is then proposed the JPEG lah, JPEG 2000, sorry. So in JPEG 2000, in JPEG 2000, the DWT is used. So DWT is the wavelet transform, and DWT is actually providing a better uh, DWT would be provide a better in terms of it consists of the information from spatial domain and also the frequency domain. So always remember, DFT and DCT, we only have the frequency domain. We don't have any information from the spatial domain. Spatial domain would be referring to intensity, the change of intensity, rate of change of intensity, and this and that. Basically, it is dealing with the pixel value lah. Okay, in most of the time. So when you convert to frequency domain, so basically you will lose all the information in the spatial domain. So by using DWT, you are actually I mean have both of these value, which means the value from the value from the frequency domain and the value from the spatial domain. Okay, so that is why DWT would be a bit complicated as compared to cosine, which is the DCT, but the appearance or the result is more appealing. Okay, so JPEG 2000 is based on wavelet compressions. Let me remove this one. It's based on wavelet compressions compared with DCT based compression used in Jetpack. So Jetpack 2000 standard aims to provide a better compression efficiency, improve subjective image qualification, and conditions functionality compared with Jetpack such as the region of interest. Region of interest coding. In particular, Jetpack 2000 address the following items. So the first of all, Jetpack 2000 offer excellent subjective qualitative a bit below 0.25 bpp, which cannot be achieved by Jetpack compression. The transmission in noisy environment. Jetpack 2000 provide improved and error resilience for transmission in noisy environments such as wireless network and internet. Okay, uh, this would be the, I mean, how Jetpack 2000 is being outperformed Jetpack lah. But nonetheless, as I mentioned previously, is sometimes the application or the software being used or extension being used in the computer by default, it is very, very dependent on the highlights or the common practice or the popularity of the software itself. Okay, but nonetheless, it's very important for us to know the difference between Jetpack 2000 and Jetpack lah. Okay, but we also should aware that the Jetpack 2000 is not something well known to the public lah. So that is why most of the manufacturer not even consider to put in the Jetpack 2000's extension in our computer. So this would be the one moment. Let me check. So basically what to check. Okay, am I once 88? So I'm right M1 this is actually to write in the I mean read and write, this space is for write. So once okay, so when you declare once 8 which means you have a 8 times 8 pixel group 8 times 8. Okay, once which means everything is one so which means this is a white color image, and this is also once 8 times 8, and but the only difference is JPEG and also bitmap okay. So let me check what to see. Okay, for this one, when you have bitmap, even eventually the initializations of this M1 is actually the same because M1 once 8 times 8. This is M1 1 8 times 8. But when you save, I am right M1 using different extension, the data value, I mean the size is actually different. Can you see? This is 1.11 KB. This is 332 bytes only. Okay, the difference is like 10 times. Okay, so comparison between JPEG compression and JPEG 2000 compression. This is the original image. So JPEG compression and JPEG 2000 compression. Comparison of the reconstruct JPEG and JPEG 2000 image compressed as 0.25 bpp. The blocking effect can be clearly seen for JPEG compressions due to 8 times 8 pixel group, but this is not a problem in JPEG compression. So both of these image is being compressed. Okay, left and right image. This is the original input image. This is the output of JPEG compression, and this is JPEG 2000 component compression. So as you can see, that is because the pixel is processed in, I mean the pixel block it is processed in 8 times 8 pixel group. So that is why you would found that all these are very blocky. Eventually the noise is block by block. Okay, so all these but when you look into the JPEG 2000 the color would be better I would say. The color will be better, and there is no blocky feel over there. That is because the compression ratio, not the compression, but the compression method is not by 8 pixel block So that is why the appearance after the compression would be different. So summary for several image extension. So let me check. JPEG and JPG or JPEG would be loosely. GIF and the GIF would be lossless, PNG would be lossless, TIF or TIFF would be lossless and lucid. Always remember in Jetpack 2000, Jetpack 2000, the algorithm can be lossless and lossy. Okay, so this would be the advantage. If let's say you want to have a greater, to have a greater compression rate, but you don't really need to decompress or recover the original data. So perhaps you can shoot Jetpack, okay, or the compressions from the compressions Jetpack 2000, but with a higher rate of compression. Okay, but if let's say you think that I need to reconstruct the original image, then perhaps it's not a good idea for you to use Jetpack. You may select the some others extension which allow you to compress the data with a smaller scale. If let's say this after the compress of data, the total storage size is acceptable by you. Okay, so again, this is depends on applications. If the trade-off is that you don't want to trade off with any you don't want to compromise with any storage size, so perhaps you don't need to perform any compressions. But if let's say you want to compress the data and you hope that and you hope to recover the original image later on, perhaps you can choose the JPEG 2000. Okay, which means you can have compressions, but later you can reconstruct the original image. But of course, the compression rate or compression ratio will be smaller. Okay, and again, JPEG 2000 does have two different types of compression algorithm, which is lossless and lossy. And always remember the compression techniques. I mean, lossless and lossy is not meaning, I mean, it's not meant to use on or to use or to describe the um, any image extension, but the algorithm to perform the compression. Okay, so if the algorithm can be reconstructed later on, so that is considered as lossless. If the algorithm after compress cannot recover the original image, so that is considered as lossy. And most of the time, lossy would have a higher rate, I mean, allow higher rate of conversion, but for lossless, the compression rate it will be very limited. Okay, so this is the difference between the lossy and lossless, and also Jetpack 2000 and also Jetpack. Any questions regarding this chapter? Perhaps Jetpack flowchart. Perhaps anything like if you have anything to raise, you may either put in the chat box, or you can just turn on your mic to ask. Any? On the count of three, three, two, one. None. Okay. If none, then that's all for this chapter lah. Okay. So before we start another chapter, yeah, I have uploaded the another chapter in the Google Drive. You may download this. Download the chapter which is morphological image processing. Um, we take 5 and then we back here by 4:50. And we continue with the next chapter, which is chapter 7. Thank you. All right, so welcome back. Give you a small, introductory to this chapter. Morphological operation is part of the, I would say most of the time, um, it would be implemented as part of the post-processing method. Okay, so in image processing, usually we have pre-processing, pre-processing followed by um, segmentations, followed by post-processing, and feature extraction, and then classifications. Okay, so this is the most common steps in image processing. And of course, it's still very dependent on the application because uh, some of the image processing don't really require pre-processing or don't really require post-processing feature extraction and classifications because not all involve classifying. Because when we involve classification, usually we have uh, at least binary groups, which mean yes and no, one and zero, good or bad, cancer or non-cancer, something like that. So okay, you don't need to perform any classification if let's say you have only one group lah, because everything will be belongs to that particular group. So one moment. So that is So morphological operation is, most of the time we are implementing in post-processing, okay? And and of course, as I mentioned just now, it can be implemented as part of the core processing. Usually we have a core processing here, lah, okay? But most of the time we are using it techniques such as segmentations, clustering, this and that, okay? As part of the core processing. So morphological image processing is usually we deal with the size, the morphological of the features or the object. Morphological would be the geometrical appearance, uh, is it circular in shape? Is it solid in shape? Is it elliptical in shapes? Is it big? Is it small? Something like that. Everything regarding the geometrical appearance of the object. For example, you have an object such as this one, or you have a hollow object like this one, or you have a elliptical object like this one, or you have something like this one with many different spot inside. So you can actually calculate, for example, the this one you can actually measure using circularity. If it is very circular in shape, so perhaps it would be approaching to one, and if it is not circular in shape, it would be approaching to zero. And this is to determine if the object is a hollow in shape, which means empty inside. Okay, and this is to determine if it is elliptical. How we know is it elliptical or not? You can actually measure the uh, uh, major exit and the minor exit. So if your the ratio of minor and the ratio of minor and major exit is more than one, which means you the length of the major exit is double or maybe 1.5, depend on the threshold you set against the minor exit. So you would expect to have an elliptical shape, okay, ellipse shaped object. Okay, and for this one, because there is part of it is hollow, which means the white color is the hollow background. So for this one, if you calculate solidity, perhaps you would get a very low value of solidity. And for object like this one, it is very solid. So when you calculate solidity, the value would be greater lah. Okay. So morphological is the any process that deal with all kind of these geometrical arrangement, the the appearance and etc. Okay, so it is part of the I would say it is main not main but very important or fundamental of image processing. Okay, so basically for morphological, you can as I mentioned just now, you can are dealing with the geometrical appearance of an object, and when you deal with geometrical of an appearance of an object, you are dealing with the shapes of the object as well. So you can actually to perform to enlarge the object. For example, you have a small object. After you perform morphological operation, you can enlarge it to become something like this one. Or you have a this object, and after you perform operations, the morphology operation, you can shrink the size to become a something very small, and etc. Okay, so this would be the way that we are part of the way that we process the image and to obtain the uh, object of intended. Okay, so this is part of the I think this is part of the very important part of your assignment as well. So this is the table of content with the fundamental and of morphology, introduction to morphological image processing, erosion, dilation, opening and closing. Okay, so these two are the basic one, and these two, opening and closing, are the combination of erosions and dilation. Just that you perform which one first. Okay, erosions is to erode which means reduce inside. Dilate, dilation is to dilate inside, which means increase inside. So opening and closing would be the combination. Either you apply erosion first, followed by dilation, or you apply dilation first, followed by erosion, and you can able to get opening and closing. So opening would be exactly as per the terms, which means you open something else. For example, you have two cylindrical, and this two cylinder is connected by a string or black line. So you want to open this one, so perhaps you can use open. Okay, so if you, let's say you have, something like this one hollow, and you want to close here, so perhaps you can use the operation closing. So after you perform closing, you will get something like this, and after you perform opening, you will get a separated object. Okay, this is especially important when you segment the object which is closely located to one another. For example, to segment the nuclear cell, to segment the the rice grain, to obtain maybe some of the worms or any other pets in the grain. Use image processing to identify the pets in the grain or the fruits and etc. Okay. So morphology is the study of form and structure of things, object, and in particular. Which means when you, when we deal with form and structure, we are dealing with the geometrical structure lah. Okay, for example, you can describe the structure lah. For example, circular, elliptical, rectangles, this and that. Morphological image processing is a broad set of image processing operations that process image based on shapes. So the field of mathematical morphology contribute a wide range of operators to image processing. The operator would be the operator here would be part of the local processing. I hope you all still can recall, we learned before the point processing, local processing, and also geometrical processing. So point processing is something like thresholding. You perform only, you process only a particular point. For example, setting a threshold at 60. So if the input image, the intensity of a particular pixel is more than 60, so you might want to set it to 1, and those pixel with intensities lower than 60, you want to set it to 0, something like that. So you only design or process the image solely based on the particular or a specific pixel alone. So that is point operation. And for local operation, you are not really only consider the center pixel or the particular pixel, rather you are actually consider the neighborhood as well. Okay, so let's say you have 3 times 3, this is your center pixel. You don't really consider only the information in this center pixel, but the whole one. Okay, but of course this is very dependent on the size of your filter or the size of your window. I hope you all still can recall this. Sometimes we call it as canal, we call it as mask, we call it as a window, and etc. Okay, so in morphological operation, we actually call this as a structure element. In short, we write in it as SE lah. Okay, structure element. Okay, so and this is also each of the structure element is also seen as a operator. Okay, which means plus or minus, those are operated to image processing, all based around a few simple mathematical concepts from set theory. Okay, so basically the morphological operation is actually from the set theory lah. Set theory is like a subset of union and etc. So introduction to morphological image processing. The operators are particularly useful for the analysis of binary image, and the usage include the edge detections, noise removal, image enhancement, and image segmentation. Okay, so that is why I say that erosions, dilations, opening and closing would be used for post-processing, but at the same time, it can be used to segment something else. Okay, for example, you want to separate the item which is connected together, so you can actually apply the morphological operation to separate it and actually segment two different objects individually. Okay, and we also can perform edge detections. The way we perform the edge detection here in is a bit different from those we detect using the Kenny, Robert, Privet, and also Sobel, because we still able to identify the edge of the object, but the approach is different. Okay, it is not looking at the intensity change, finding the first deviations and then cross and then get the center point. No, not something like that, but instead it's much more something simpler. Okay, but in fact the edge detection here, it might not be that effective lah. I'm not to it's sometimes not to say ineffective lah, but it is not so we don't really know is it accurate or not. For example, if you have a very thick edge, so you after you perform the edge detection using the morphological operation, the edge obtained might not be the edge which is the correct edge lah, might not be the correct edge, but nonetheless the overall detection method, I mean edge detection method using morphological operation is quite simple. Okay, another thing is that we are usually perform the morphology operation in binary image. Okay, because we need to know the foreground and background. That is why we are usually perform in binary image. Of course, you can perform in grayscale as well, and it's quite common to perform in grayscale. But nonetheless, for the subsequent slide, we are actually explaining using the binary because we want to know the backbone theory first, and then later on we move towards grayscale, which is a bit, I mean, the intensity is a bit different. Because for the binary, we only have 0 and 1, right, which is black and white. But for the binary, but for the grayscale, we have 0 to 255, which is 256 value. So this slide shows the example of a binary image whereby you have a black color pixel and also white color pixel. So this is the original pixel. And after erosion, you will get something like this. And after dilation, you will get something like this, opening and closing. So I hope you're aware the difference here is that this is the original image. So after perform the erosion, the size of the object is actually reduced. Let's say the object of interest or the foreground is black color. It's black color, not white color. Okay. So after you perform the erosions, you will find that the total area of the black object or the black pixel is reduced. Okay, which means, and also the leg here is removed. Okay, but when we of the object of interest is increased, so which means that you have a thicker leg here. The hole here is being removed and filled up with the black color pixel, and this is opening. What is the difference between opening and the original image is that you have removed the leg over here. Okay, but nonetheless the gap here, the hollow gap here, is still remain unchanged. And as you can observe, the original, the size of the size of this part is more or less same as the original image, but without this leak. Okay. And for closing, you will find that this value, the size of this pixel, of course, there is a minor, you can observe that actually the pixel is a bit increased, enlarged in size. But nonetheless, when you compare to the dilations, the entire image is like, yes, you did close the hole over here, and you remain the mini leg over here, but the effect of dilations or the discrepancy of the closing image, output image, and the original image is a bit similar lah. Okay, when you compare with dilation, the entire image pixel, the black color pixel is being increased significantly. Okay, so as per the descriptions, opening is to open something else. So for this case, you have opened up or removed the mini leg. And for this case, you perform closing, right? So you close up the hollow here. Okay, so that is why no longer there is a hollow gap over there lah. So this is the original input image, which is in grayscale. So you perform using Kenny, Previt, and also Robert. Okay, but of course, don't forget for Kenny, you can actually uh, control the threshold, the upper threshold and lower threshold to get a better image lah. Depends on you can actually set the threshold upper and lower in order to um, change the degree or towards level you want to segment the edge lah. Okay, but for period and sober you cannot. So this is the original image of a fingerprint. So after skeletonizations of the original image and skeletonization on auto threshold image. For the morphological operation, we are skeletonizations is actually like, you know, you remove the flesh of a human, remove all the organs of the human, and left only the skeleton. Okay, so this is the way. This is one of the basic image processing algorithm as well to obtain the skeleton of the image. Uh, to obtain the skeleton of the image is especially important for like uh, applications such as it would be very similar to applications such as water shouts and etc. Water shout is actually based on the theory. This is a water bank, and then you fill in water, and then this is another bank. So this is from the side view lah. When you observe from the top view, you would be expect this is one water shout, this is another water shout, and then actually you are segmenting the image into different compartment. I think it's a bit vague over here. For example, you segment this into different compartment. Okay, so these are one of the example of water shout lah. Okay, and for skeletonization is to find the skeleton. So uh, why we need to find the skeleton? For example, you have a leaf, or maybe you can have, you know, how should I put this? Skeletonization is actually can be used to partition the image into different compartments. So this is especially important when you perform this in tumor region segmentation. You can try this out, and also to segment the oil pump using the drawn image and many other different application. And one of it is to detect the fingerprint. Okay, because this is the input image. It is, you can observe that this is a fingerprint, but it is very difficult for you to analyze it. So you need to perform the skeletonization. And after you perform the skeletonization, you would be able to get the fingerprint line clearly. Okay, so after that, you can scan this and search in the database to get, to know whose this fingerprint is belong to whose, something like that. So the fundamental oh, okay. So for this one, it's something very, very similar to age detection. Okay. Another thing that you can actually perform so-called the age detection is that you convert this image to a binary image, which in black and white, and then you perform erosion, perform dilation, and then you perform erosion, and then dilation minus by erosion, you will get your age image. Okay, I hope you can get this idea, which means, you have this is your original image. First of all, perform dilation. So you expect to have a larger size, and then erosion. So you would expect to have a smaller size. So dilation minus erosion, so you will get the age. Okay, I hope you can get this idea. The original image, dilate it, so you will get bigger in size, right? And then you erode it, so you will get smaller in size, right? So for beginner lah. Okay, but actually you can make it into different shape, increasing the size of the structure element. Maybe you extend the size of the cross shape, or maybe you just want 3 times 1 structure element, or maybe in another way around 1 times 3, or maybe a circular shape, maybe a circular shape structure element. So with different kind of structure element, I mean the shape of the structure element, your output will be different. So if not mistaken, in MATLAB, you can actually perform erosion, dilation by using different shapes. As I can recall is that sort of this disk, yeah, something like that lah. Okay, so these all these you can try to apply using different shapes of the structure element in MATLAB. You can compare the appearance later on. Okay, because when you are applying using line, using this, using circular, the effect will be different. Okay, so if you want to remove something, which means your object is all in circular shape, so perhaps you can use this, something like that. If everything in your input image is in a line shape, so you can use a line to remove. Okay, the essay is positioned at all possible locations in the image, and it is compared with the corresponding neighborhood of pixel. So small set or subset image or sub-image used as a moving window to props an image under study for properties of interest. So essay can be any size, any shape. Basically, the theory or the philosophy behind the morphological operation is very simple. But this question can be extend to very complex because some structure element could be very weird or could be very different in size. So I mean, you have to be very, I mean, very strong in fundamental lah, which means how is dilation being applied, how is erosion being applied, how is opening. I mean, start with erosion first or dilation first, and how to perform closing or opening, something like that. Okay, it's very important for you to know this uh, in order to answer different kind of question with different structure element. Okay, so however, for simplicity, we will use rectangular SE with their origin at the middle pixel. Okay. Another thing is that in this slippers, I always give you example. The center point is always at the origin, or the center point is always at the middle pixel. So in real case, this is not a must. Okay, not a must at the same center lah. So as you can observe, SE is a small image that is used as a moving window. So this is actually a filter lah. The dots denotes the center of SE, and this is actually the structure element. But in real case, structure element do not appear in such a shapes. But instead it will appear in something like this one. Okay, because it cannot appear like which is did not omit any 3 times 1 what type what lah, okay, 1 times something else okay. So if let's say you want something like this one, so for sure the uh pixel will become, you need another pixel to compensate this corner. One moment, let me change my earpiece. I think out of battery already. Okay, can you all hear me? Let me see if I'm change it up. Can you all hear me? Okay, I think okay. Okay. So that is why this is how actually the shape looks like lah. So but of course without this pixel are empty pixel, and the origin is at the center point, which is the black dot, reflected by the black dot. And for this one is okay because you don't need any corner pixel to compensate. And for this one, you need extra set of pixel to compensate at the corner here. Okay, so this is why you need to compensate with the white color pixel lah. So ideally, this is how the pixel looks like. But in most of the cases, we are using this one lah. Okay, for I mean, to show an example. So unlike convolution canal, as or hits. So fit and hit is image. Hits is that any one pixel in the structure element cover and on pixel in the image. So if let's say you have A, B, and C, A is should be fit lah. Okay, because A everything in the structure element is being covered, right? Would be, which means you only hit a corner. And C would be nothing related lah, because you have nothing I mean overlap between these two. Okay, so again A is fit, which means all of the pixel is being overlap on the features or the object lah. Okay, and B is hit. Why? Because you only have one corner or part of the structure pixel denotes the background. Um, this is actually you need to check back with the software, because not all software um use the white pixel as the foreground and the black pixel as the background. Okay, yeah, just now I forgot to explain about foreground and background. Foreground is the object of interest. Background is the object is irrelevant to you. You have an image. So this is cherry lah, let's say. Okay, so cherry is your foreground and the rest is the background. Okay, so if you know, rice grain. So the rice grain is appeared in black color. So the black is your foreground pixel and the white is your background pixel. You always, I mean, you have to try and know what is the foreground and what is the background pixel in your software. For example, in MATLAB. Okay, if you don't know which one is foreground, which one is background, the effect that you apply would be inverse. Okay, which means you uh, for the erosions, you are meant to expand. Sorry, for erosion, you are meant to shrink the foreground, but to expand the background. Can you capture the point here? Although in previous slide, I keep on mentioning that erosion is to shrink in size, right? That is because you shrink the size of foreground. But in any pixel, it's impossible for you to delete the pixel. So when you shrink the size of the foreground, you are actually expanding the size of the background. Can you get what I mean? Which means if let's say you have this image, so after you perform erosion, this red color is actually your foreground. After you perform the erosion, you will actually reduce in size, right? So which means shrink the size of the foreground, which means your red color dot is, I mean, the size of red color dot is being reduced to become a smaller dot, but you are actually expanding the background because the background area is being expanded. Why being expanded? Because it takes up all the surrounding pixel here, which is originally occupied by the object of interest. Can you get what I'm trying to say? This is then, so that is why it's important for you to know which one is foreground, which one is background. Okay. Such that if you perform ground is actually, I mean, after you perform erosions, why my this is what you want, okay? But you don't know in this system or this software which one, the red color or the black color is the background or the foreground. But after you perform erosion, you found that, oh, why this red color dot is bigger in size? I perform erosions, right? Supposedly the object of interest should be reduced in size, but what you observe is that the red color dot is expanding in size. So which means the region of interest is this one. So this, the red color dot here is is a background, but the foreground is the black color here. Sorry, white color here. Okay, so you need to if you want to process using this one, I mean the erosion and dilation directly. So you need to complement the image so that you get an image something like this one. You get an image like this one. So after you perform erosion, you would expect you have smaller size. Okay, can you get what I mean? So it's important for you to know what is foreground, what is a background in your software, especially in MATLAB when you are using these to process. So for a binary image, white pixels are normally taken to represent the foreground, and while black pixel is denote the background. Always double check this one because this might not true. I mean, this may not be true for all different kind of software. So the foreground would be one which means white pixel, and the background would be zero, which is the black pixel. So if let's say you perform erosions, you perform erosions which is reduced in size of object of interest, can I know would the area of black sorry, would the area of white pixel increase? Let me pick someone to answer. Junwei Lim, if let's say we have white color as foreground, black color as background, if I perform erosions, would the foreground or the white pixel increase in size or decrease in size? I'm performing erosion. Foreground would be increased or reduced in size. Can Chunwei Lim answer these questions? Increase or decrease only? You can put it in the chat box. Let me repeat again. You have foreground, which is white color pixel, and you have background, which is black color pixel. And if I am going to perform erosions, can I know if the foreground or the white pixel would be increased in size or decreased in size? Is Junwei there? Let me pick again. Ernest, is it very confusing? So that is why decrease, yes, decrease is correct. Okay, because erosion is meant to decrease in size or shrink in size. And let's say, and since the foreground or the white color pixel is the foreground, so when I perform erosion, so basically the foreground will be reduced in size. Okay. Basically the answer is just 50%, either increase or decrease. So try to make yourself very clear on this one. This is very, I mean, the philosophy of morphological operation is very simple, but it can be very complex when you need to think, which one is foreground, which one is background, which one is reduced in size, which one is increased in size, and so on. Okay. So this is the, as I mentioned before, the morphological operation is actually a basic set theory. It's based on basic set theory. So you have all this kind of the symbol, but I don't think I will explain the symbol here. You can just refer to this because it would be pretty clear when I explain using illustrations later on. So this is a element of one of the element of, and this is not an element of which mean this is part of it okay, M is part of N S, and MC is not an element but it is just intersect with each other. So this symbol is referring to intersection, this is referring to union, this is referring to uh exclusion of B, okay, which means any part uh excluding B, okay, because this part is shared between A and B, right? So since you want to exclude from B, so you only get this part. So consider two image A and B in Z power of 2. The Minkowski sum can be defined as this one. Don't worry, you don't need to memorize this one. So Minkowski additions is obtained by translating A by element of B and taking the union of all the resulting translate. Minkowski subtraction is obtained by translating A by every element of B that intersect is performed. So this is subtraction and this is sum. Okay, so we will go into erosion. Before we go into erosion, any questions from any of you? We will learn erosion and followed by dilation and opening and closing. I think I will explain in depth for erosion, and dilation is just inverse of it okay, because erosion is the decrease in size for the foreground, and dilation is actually increase in size for the foreground, and opening and closing is just the combination of erosions and also dilation. Okay, so I will explain in depth for erosions and for dilations and opening and closing. So basically just the same, just that increase in size or decrease in size. That's all. Okay, I suppose no questions. If you have kindly raise the questions, and if you have doubts, feel free to put it in the chat box or whatsoever lah. Okay. So erosion of image A by SE. SE is structure element. B is given by this equation. So this sign, this equation, this sign shows the erosion. Okay. You have to know the sign of erosion. For example, actually erosion and dilation is just minus or plus lah. Okay. Nothing special. So erosion will be minus and the dilation will be plus. This is the image and B is the SE, which is the structure element. So the SEB is positioned with the origin at X and Y, and the new pixel value is given by using this rule. Okay, 1 if B fits A, 0 otherwise. So basically it is very much likely to do the thresholding lah. Okay, the condition set will be very similar to the thresholding. So for each foreground pixel is called the input pixel. The erosion step is as follows. First of all, superimpose the SE on top of the input image so that the origin of SE coincide with the input image position. So basically, you just superimpose your structure element on the input image lah. Okay, just superimpose in it. If for every pixel in SE, the corresponding pixel in the image underneath is foreground, then the input pixel is left as it is. Let me repeat that. If for every pixel in SE, the structure element, the corresponding pixel in the image underneath is a foreground, then the input pixel is left as it is, which means nothing changed. If any of the corresponding pixel in the image are background, however, the input pixel is also set to background. Okay, let me go into example so that it's clearer. Okay, so X denote the origin. So this is the origin. Let me remove this first. When superimpose the SE on the original image, this is the original image, and this is the process image or the output image. So the green color here shows the pixel which is being removed. So which means this is the original size, which is blue in color. So after I perform the erosions using this structure element, this blue color is those pixels that remain unchanged. Okay, and green color pixel is those pixels being removed after the erosion. Okay, let me repeat. So this is the structure element. So orange color denotes the shapes of the structure element, which is a cross shape lah. And the cross spot here shows the origin. Okay, origin. So I will apply this one on top of this. Starting from this angle, I mean not angle, starting from this pixel, and then follow to next pixel, next pixel, next pixel, next pixel, and so on. Why show like that? Okay, so this start from this pixel and then followed by this pixel, and so on. Okay, so this is how the actually the way the way the SE is being um apply or superimpose on the original image is exactly the same as the median or mean lah. Okay, let me remove this first. And this the blue color again, the blue color is the original object of interest or the foreground, and this is the rest is the background lah. So after apply the image processing, the morphological operation, which is erosion, so only left 1, 2, 3, 4, 5, 5 pixel, and the rest of this green pixel is the pixel being removed. Okay, so let's follow the process here one by one. So this is the original image. So first of all, I apply the canal to the first pixel here at the center, and then continue to move to the next pixel. Because nothing overlaps, so I just proceed. Again, move to this pixel, nothing happened. So now I move to this pixel, nothing happened again. So move to the next, next. Why not? I mean, actually this is overlap, but why I say nothing happened is that because we only concern at this center pixel. If center pixel is not overlapping with any of the original pixel, so consider as nothing changed. Okay, so nothing changed. So we continue to the next pixel here, next pixel here, here. So we move to the next line, the next pixel, the next pixel, and yeah, now the center pixel is overlapped on top of the object. So since since not all the pixel underneath the orange block are foreground, thus the output pixel at X is a background, which means it's being removed lah. Why? The principle is that since not all the pixel underneath the orange block are foreground, thus the output pixel is removed. So we we will remove this pixel. Okay, and we proceed to another one. The center pixel is now here, and again since not all the pixel underneath the orange block are foreground, thus the output pixel is converted to background. So we remove two block and we continue. This block is not all block underneath the orange block is foreground, so this is considered as background as well. Okay, so for I will skip for this and this because nothing happened, right? Because there is no the center pixel is not overlapped with the object of interest. So I back to here. So again, we remove this one. Why? That is because not all the pixel underneath the orange block is are foreground. So we remove this one. So we go to the next. Since okay, this one the location is here. Let me change another color. The location is here. Since all the pixels underneath the orange block are foreground, thus the output pixel at X is foreground. Okay, because this is the structure element. Okay, so all the pixels under this cross sign are foreground. So the current pixel at the origin here, this one is also foreground. Okay, so let me continue. So again, this obey the rules. All the pixel underneath the structure element is a foreground. So thus, this is also a foreground. And we continue this one. Oh, it is not a foreground. Why? That is because that is because not all of it. This one is not foreground. Okay, so this is so the origin here will be removed and act as a background. And we continue. Not obey, so remove. Oh, obey. So we reserve this one, and we obey again, reserve this one, and not obey, delete, not obey, delete, obey, retain, not obey, delete, not obey, delete, not obey again, delete, and the last one, not obey again, delete. So afterwards, that is how you get this one now. Okay. Actually, you can compare back. This one we have a full, you know, so that is why we retain this pixel, the blue color, and for this one we have a full pixel, so we retain this one, and the same apply to this and this one. Okay, so at the end all this green color, the green color here would be the image pixel being removed, and only this one, I mean only this pixel is being retained after you apply the morphological operation using the shape of this one with an origin here. Okay, can you all understand? For this one, I need feedback. Maybe if you don't understand, uh, please raise the questions. I hope because this is quite simple, but somehow it can be very confusing. So yeah, so that is why I do it slide by slide, moving the one point to another point, so that you all know. Uh, I mean, take this as an example, lah. So after you learn this example, basically the subsequent one would be very similar, lah. Okay. So any question regarding this one? I mean, the way we apply erosions, any people, anyone still not understand? And of course, if you need time to comprehend, it's okay, because I understand that sometimes would be very confusing. I wouldn't say this is a complicated theory lah, but it may take time for you to understand. Okay, but anyhow, this cross sign is a simple structure element. Okay, with origin at the center. But actually, you can see this as you know, eh, you can see this as a rectangle like this one. Okay, just that the pixel over here is blank pixel lah, which means zero lah, nothing lah. Okay, yeah, something like that. Okay, so any question regarding erosions? Anyone don't understand why? I mean, how you get this? How you remove the green color until you get this one? On the count of three, two, one. Okay. Feel free to understand first. If you cannot understand, then let me know. But I think this one, you don't need to. I mean, by looking in the mathematical equations, of course, if your uh, uh, mathematic theory is very strong, perhaps you will understand. But to me, I would prefer to do some example. For example, you can input an image, maybe basic image with you can get retrieve from Google lah. Any image which is binary image, and then you perform the erosion and perform the dilation using different shape like this line, rectangle, and etc. So you observe the output image, So I think that would be easier lah for you to understand what is erosion and what is dilation, and followed by opening and closing. Okay. So after perform an erosion, the SE erodes. SE is the structure element. Erodes away the boundary of regions of the foreground pixel, which means the white pixel typically. So area of the foreground pixel shrink, which means reduce in size, and hole within those area become larger. Why is it hole within it become larger? So actually you can assume like, you have a circular shape. This is your image. And this is the object of interest or the foreground. So after you perform erosions, you would expect to get something like this. Oh, this is too small. It's difficult for me to draw. Okay, something like this. So let's say you have an image like this one. Okay. So after you perform the morphological operation, for example, erosions, you would expect to get something like this one. Actually my drawing is not so good. So that but actually I mean it is reduced inside. What I want to reflect is that it reduced inside because the thickness here is being reduced, and the hole inside, which is the background, is increased inside. Why increase inside? As I mentioned just now, erosions is actually meant to shrink the size of the foreground, but increase the size of the background. Okay, so for this one, this is the foreground, this is the background. So after you perform the erosions, you would expect the pixel number of pixel of the foreground is being reduced or shrink in size, but the background is increased in size. Okay, so this is increased in size. So that is why the gap here, maybe the original gap is something like this one. Okay, something like this one now. Okay, so which means the F, the foreground is reduced in size, reduced in this area, and it is reduced in this area as well. Okay, something like that. So this is so-called that erosion. So that is why before you perform any erosion, you perform any dilation, it's good for you to know what pixel is the foreground and what pixel is the background. If let's say the white pixel is the background, then you actually want to perform the operation on the black color pixel. You just need to complement the image. I think complement image is just simply by, for example, I am read your directory, your image equals to A, and then um, A, how I am complement. I think it's I am complement. Yeah. Let's say I am read your directory is equal to A, and then I am complement A. You will get B lah. Okay. Or no, B will be a bit blur. AA. Okay. Let me check. Is it I am complement? I am complement. Yeah, it's correct. It's just like inverse lah, which means white to black and black to white. Okay, so just use the I'm complement to change the color, which means if let's say this is black color, so after you perform I am complement, this will become white color and this will become black color. Okay, so you see the area of this white region and area of this is being shrink to very small and very small. Okay. In a binary image, if any of the pixel in the neighborhood defined by SE is 0, then output is 0. So actually erosion can be used to separate the two objects which is joined together, something like this one. Okay. But nonetheless, after you perform erosion, you would expect a reduce in size. Okay. You would expect a reduce in size. So that is why the size of this one and this one is, is smaller, and this is small as well. So for this one, you can actually use erosion to reduce, but actually you are not only reducing all these, all these object, but you actually reduce the size in overall as well. So this is the effect of using erosions and dilation. And um, as I always say, you have to know your application. If you don't know your application, it's very hard for you to, you know, what is being teach over here. I mean, in the MTAA is actually basic image processing technique. So you can't really say that, oh, I want to do this, what I should do. No, I cannot tell you something like that. I only can teach you some, I mean, plus, minus, multiply, divide, integration, differentiation. But if you want to come, I mean, when it comes to application, you have to know what you want to achieve, the intended outcome. And you can achieve the intended outcome by using all these arithmetic or all these operations learned from the syllabus. Okay, so you can later on compare the erosions to remove the two joint object, and also compare with the opening morphological operations, which is I am erode, I am dilate, I am open, and I am close. Okay, and all these are associated with different SE lah. You need to declare the SE first, and then of course you can declare your own SE, or you use the SE structure element in the MATLAB by default. Okay, so you can try this out by your own. And yeah, any questions so far for erosions especially? No. Okay. Sometimes I quite worry because I cannot see your face, so I cannot know if you are really understand or not. But if you are not understand, maybe you take your time to study first, and you can raise the question to me in the next lecture. Okay. But for your information, this Thursday we don't have any lecture because we already conduct the replacement class last 2 weeks, I think. And we don't have tutorial for this week because this is odd week. We have tutorial in even week only. Okay, so this is week 7. If you don't have any other further questions, so that's all for today. And thank you. If you have any question and you want to ask now, or maybe later on, you feel free to WhatsApp me, or maybe email me. Okay, I will reply you very soon. If else, then you jot down, maybe you'll ask during the next class. Okay, so that's all for today, and thank you. Bye bye.